Hey everyone. So in this lesson we're going to continue with what we were talking about last time. Now last time we were focusing a lot on factors and just what factors are, and the reason for that is that if we're moving on now past factors towards common factors and highest common factors, and then we want to be able to use that in our future units, then I want to make sure that you have a really proper understanding of what factors are now. Now hopefully you have a pretty solid idea now of what factors are. So we're going to move right along into actually finding common factors between two numbers. But yeah, so just to review from last time, factors are numbers that are multiplied together to give us a larger number, as long as we're talking about positive integers, right? So if we've got like 2 times 3 equals 6, then we get that 2 and 3 are both factors of 6. Alright, so we were just talking last time about what factors are. There was also that thing about divisibility rules, that if a whole number is divisible by another whole number, then that divisor is also a factor, and the answer to that division question, the quotient, would also be a factor. So that's like if you had 6 divided by 3 is equal to 2. So in this type of example, then you're starting with the number 6, and the number 3 and the number 2 are both factors of 6. Which can be shown in this way as well. So we were sort of focusing on that last time, and we're not going to focus too much on that because I want to move on to actually finding highest common factors. So if you are still sort of struggling with that, then let me know and I can make another video on it, or you can go back and rewatch the last one just to see it a second time and get that stuff really clear before we move on too far. So what we're going to do this time is we're going to start off by finding factors of numbers, and in particular we want to find common factors between pairs or larger groups of numbers. So let's start with numbers like, let's say we've got the number 16 and the number 24. Alright, so we want to find the highest common factor. We'll eventually get to highest common factor. Right now we want to find the factors of each of these two numbers. And then, so the game plan is we're going to find the factors of 16, we're going to find the factors of 24, we're going to find the common factors, the factors that they both share, and then we're going to find the largest one. So we're starting off by finding the factors, then we're going to figure out which ones are common, and then we're just going to pick the largest one, and that'll be our highest common factor. So just the way with lowest common multiple, there were 3 ways to do this. There are 3 ways to do HCF as well. So basically what we're going to start with is the first method, prime factorization, which is something we talked about before with our lowest common multiples, right? So that was the bit with the factor trees. So if you started with the number 6, you break it down into a prime number times another number, and then if one of those numbers happened to not be prime, then you would go again. But, of course in this case both of them are prime, so we'd be done there. But basically we're going to make those factor trees for 16 and for 24. So the first part of the process is exactly the same as it was for lowest common multiple, and then we're going to go after that and change things up a smidge. So let's start by making the factor tree for the number 16. So we start with 16, and you can break this up any way you like. The way we broke it up when we were doing LCM is we would find the smallest prime number and put that here, and then we'd put whatever else we needed to, because this is going to be a product. So we'd take a small prime number, which in this case would be 2, since that's an even number, and then we would put, okay, 2 times what is going to give me 16? And we get that 2 times 8 is going to give us 16. You can go this way. It's also perfectly valid if instead of 2 times 8 you did 4 times 4, and then you just broke both of those up later. which is something I think I've mentioned before, but I'm going to try and stick to going with the smallest prime number that you can get from this. So we're breaking up 16 into the smallest prime number that we can, and then whatever other factor can be multiplied with this prime number to give us 16. So in this case we've got 16 is divisible by 2, so that 2 goes down here. That's the smallest prime number. 2 times what is going to give us 16? 2 times 8 gives us 16, so we put the 8 over there. Now 8's not prime, so we're going to break this 8 into, well, the smallest prime number that we can fit in there is 2 again. And then we get 2 times what is going to give us 8? Well, 2 times 4 is going to give us 8, so we put a 4 there. And now one more time, 4 isn't prime, so we break that up. 4 is divisible by 2. 2 times what gives us 4? 2 times 2 would give us 4. And we can bring these down as well if you want, or you could like put a circle around them or whatever. You could bring this down here, bring this down here. And so then what you're left with is this line at the bottom. These are the prime factors that can be multiplied together to give us the number 16. Right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So you can always do that check as well to make sure that, that you've done it right. So we've got those 2's all the way down there at the bottom. And so now I'm going to actually have to erase this. That's just not particularly important. I'll put the 16 and 24 over here. That's the 16 and 24 that we're working with are going to sit over there. And I'm going to get rid of this so that we can build our factor tree for the number 24. So, if we do the same thing with 24, we get that we can break this up. 24 is an even number, so the smallest prime number that we can put here is 2. 2 times what gives us 24? We're going to get that 2 times 12 gives us 24. So then we take this 12, because it's not prime, and we break that up. 12 is still an even number, so we can put another 2 here. And 2 times what gives us 12? 2 times 6 is going to give us 12, so that 6 goes over there. 6 isn't prime, so we put that, we break that up again. 6 can be broken up into 2 times 3, and those are both prime numbers there, so we can stop. We can bring these 2's both down all the way here. You don't have to bring this down in 2 steps, you could just drag it straight to the bottom. And so then we get that for 24, the prime factors of 24 are 2, 2, 2, and 3. Right? We get 2 times 2 times 2 times 3 gives us 24. So what this tells us then is if we wanted to find the least common multiple at this point, what we would do is we would take one of these numbers, so let's say for instance the 16, and we would write down all of its factors, and then we would look at the 24 and we would write down any of the factors that haven't been accounted for already. So in this case we would have the 4 2's here, all of these 3 2's here have been accounted for, but that 3 hasn't. So our lowest common multiple would have been 2 times 2 times 2 times 2 times 3. However, with highest common factor, it's going to be a little bit different. Here, what you're going to do is I'm going to get rid of, I'm just going to get rid of the title for now, I guess. Finding the highest common factor. We know that that's what we're doing. So I'm going to write down 16 is equal to, and I'm going to put like a box here because we're going to have a whole bunch of numbers and I don't want it getting confused with the other numbers that we're writing. So we've got 16 equals, and we're just going to write down this thing that we've circled down here, this product of prime factors. So we get 16 is equal to 2 times 2 times 2 times 2. Easy enough. And then 24 is equal to 2 times 2 times 2 times 3. Now for lowest common multiple, we would do that thing where we put all of the ones from one factor and then figure out what's, not accounted for. It's a little bit weird. With highest common factor, it's much simpler. You look at the 16, you look at the 24, if you find any factors that are in common between both of those, put a circle around both of them. So for instance, we've got this 2 for the 16 matches up with that 2 for the 24. So we put a circle around them like that. Same thing here, this 2 matches up with that 2. So we put a circle like this. And this 2 matches up with this 2. But this 2, so even though we've got a whole bunch of 2's down here, and we've got nothing except 2's up there, each number down here can only be matched with one number up top. So even if you have like only 1 2 down here, and then just like 10 2's up top, they can still only be matched up once. You can't do like that this 2 matches up with the one above it, and then also that one over there. You can't do something like this. That's not going to work. So that's why I encourage this use of these like bubbles that contain pairs of numbers, because that way you're not accidentally double counting any of the numbers. And then from there, the highest common factor is going to be just the product. I'm just going to kind of write this in the middle. I guess we're going to put this box here. I'm going to get rid of that. We know we had a 6 over there. Whatever. So the highest common factor is going to just be the product of the numbers that you have pairs of. So it's not going to be 2 multiplied by itself 6 times. We paired off 2's here, 2's here, and 2's here. So we take, here we paired off 2's, so we put a 2. Here we paired off 2's, so we put a 2. Here we paired off 2's, so we put a 2. So the number of pairs that you have is the number of factors that you're going to have down here. And whatever number you have contained within that bubble is the number that you're going to write down. You'll see in the next example when we have some different numbers in the bubbles what I mean if it's not clear right now. So we had a pair of 2's, a pair of 2's, a pair of 2's, so we account for that by putting a 2 here, a 2 here, and a 2 there. And we multiply those together. 2 times 2 is 4, 4 times 2 is 8, and so we get our highest common factor is 8. And so basically this means that 8 is the largest factor of 16 and 24 combined. So if you wanted to divide 16 and 24 by the biggest number that you possibly could, that would still leave you with 2 whole numbers in your answers. 8 would be that number for you. 16 is divisible by 16, but it's not, but 24 isn't divisible by 16. So 8 isn't the largest factor of 16, but it's the largest common factor between these two numbers. It's the largest common factor that 16 and 24 both share. Okay, so that's what highest common factor means. Now there's a second way to solve this, which I think we sort of talked about a little bit in the last video. So I'm going to get rid of this one now, and we're going to move on to method 2, and then method 3, and then depending on how much time is left, we'll see if we can do another example or two. Probably only one more if I want to show all of the methods again for it. But so method 2 is, I'm calling it lists, basically because we just list the factors by sort of trial and error. We just try and figure out how many different ways you can multiply two numbers together to get the numbers that you're targeting. So basically the numbers we're targeting here are 16 and 24, right? Same problem as before. So the way you can do that is if you look at this 16, you just sort of think about how many different things can I multiply together to give me 16? How many pairs of numbers can I multiply together to get 16? So for example, I could do 1 times 16 would give me 16, right? I could also do 16 times 1, that's also valid. We could do 2 times 8 would give us 16, and if we wanted to flip that, we could do 8 times 2, right? And then lastly, we could also do 4 times 4 to give us 16. Now the way I generally like to do this is I like to start with the smallest factor in front, the smallest factor that I can possibly have, and then see if there's a number that fits on the other side. So I'd say, 1 times something, 2 times something, 3 times something, 4 times something. I'd keep going. And so I get, okay, 1 times what will give me 16, and I get 16. 2 times what will give me 16? 8. 3 times what is going to give me 16? It's not going to be a whole number, so I can get rid of that. You don't have to write them all out. You can sort of go through them one at a time. Think about it. Will 3 times something give me 16? Is 16 divisible by 3? If not, you just move on. 4 times what will give me 16? Well, 4 times 4 will give me 16. Now if you look down the left side, these factors are getting bigger, those factors are getting smaller. So if the next factor on this side needs to be bigger than 4, and the next factor over there has to be smaller than 4, we're just going to start repeating the other ones that we had, but in the reverse order. 16 isn't divisible by 5, so we can ignore that. 16 isn't divisible by 6, so we can ignore that. And it's not divisible by 7, but it is divisible by 8. 8 times what gives us 16? 8 times 2 gives us 16, and then 8 is the halfway point. This is something I was sort of talking about last time with once you reach this halfway point, you can just sort of skip to the end and put the number itself times 1. So you can see we ended up just sort of flipping the order, but this way it's a little bit more organized, I guess. The factors are getting bigger this way and bigger that way, whereas over here they're kind of all over the place. Your last step, once you've listed all of these possible products, which you can multiply together to get that 16, is you're just going to list the factors that you see here. So however many different numbers you see, you're just going to write those down. We have a 1, so we'll put a 1. We have a 2, so we'll put a 2. We've got a 4. We've got an 8. And we've got 16 itself. These are, up here, these are the factors of 16. Now we can do the same thing for 24. Now I'm going to save you guys a little bit of time and just sort of go through and write down all the possible ways that you can get 24. But as I'm going through this, you'll see that for larger and larger numbers, if you're trying to solve it with this method, you're going to be here a while if you're trying to figure out every possible product of two whole numbers that'll give you the thing that you want. Right? So, and especially, even if you get all of them right off the bat, you'll end up sitting here just kind of thinking, you know, are there more? Is there anything I'm forgetting? And then you'll sort of double check and triple check, and you're wasting your time because you already found all of them, but you need to double check and triple check to make sure, because the numbers are so big that you don't just know all the factors offhand. So this method is just like when we were listing multiples earlier for lowest common multiple. It's not really the most effective once you get to bigger numbers. So here I think that's all of the ways that you can do this, and we just go through the same way we did with the 16s, is we'll just circle all the factors, we'll just write down all the different factors that we see. So we got 1, we got 2, we got 3, we got 4, right? Simple enough. So we got 1, 2, 3, 4, and then we got 6, we've got 8, we've got 12, and we've got 24. So those up there are the factors of 24. So now, between these two, we want to find the common factors. So common factors would include, well, we've got 1 would be a common factor, right? That shows up in both lists. 2 shows up in both lists. 4 shows up in both lists. And 8 shows up in both lists. So this up here is our collection of common factors, this up here. Right, so we started with our two numbers, we found the factors, now we've gone and we've made this collection of common factors, and now our last step is to go and pick the highest one. So we just take the largest one of those common factors, and that gives us our highest common factor. So we started with just factors of 16 and 24, then we moved on to finding the common factors, and then we just pick the highest one out of that list. Alright, now the last method, hopefully this is making sense so far, but the last method is very similar to the one we did for lowest common multiple with the division thing. So I'm going to call this a division one as well, for lack of a better name. Hopefully it doesn't get too confusing that both of these methods have the same name, and they were both method 3 that we've covered and all of that stuff. But you'll see that there's a very strong similarity to the lowest common multiple business, but you'll also hopefully see that there's quite a significant difference as well. So for lowest common multiple, if I wanted to find the LCM of 16 and 24, I would put 16 and 24 like this, and then I would do that division thing where we find the smallest prime number that either of these can be divided by. It doesn't have to be the first one, it doesn't have to be the majority of them, it just needs to be at least one of them, and we'd put that smallest prime number. That's for lowest common multiple. For highest common factor, it's going to be a very similar process, but we're going to separate the two numbers. So we put a 16 over here, we put a 24 over there, and we're going to do that same business with the division with those L-shaped division signs, but we're going to do it separately for both numbers. So for 16, we look at this. This is very similar to the prime factorization thing. This is just sort of a different way to visualize it, I guess. So you start with this 16, and we ask ourselves, what's the smallest prime number that you can divide 16 by? So you get 16 can be divided by 2, which is the smallest prime number there is, right? So 16 divided by 2 leaves us with 8. We do the same L-shaped thing, and we want to keep doing this until we get a 1 at the bottom. Now, what's the smallest prime number that we can divide 8 by? It's going to be 2 again. 8 divided by 2 is going to give us 4. Put the same thing. Smallest prime number that we can divide 4 by is going to be 2 again. We're left with a 2 because 4 divided by 2 gives us 2. And then lastly, smallest prime number that we can divide this by, of course it's going to be 2 again, and we're left with a 1 down there, and we're finished. But now we got to do the same thing to the 24. So we start here, and we ask ourselves, what's the smallest prime number we can divide 24 by? Now 24 is even, so that means it's divisible by 2, so we can do that. 24 divided by 2 is going to give us 12. We put this thing here again. 12 is even, so again we can divide this by 2, so we put a 2 there. 12 divided by 2 is going to give us 6. 6 is still even, so we can put a 2 here again. 6 divided by 2 is going to give us 3. And finally we get something a little bit different. 3 is not divisible by 2, so we move on to the next prime number. 3 is indeed divisible by 3, so we do that. We've got a 1 at the bottom, and we're finished. Now, much like the prime factorization thing, we're going to take the collection of numbers that we got and just list them going across. I'm going to actually move this down just a little bit. So we've got that 16 over there, and we're just going to list these numbers here all multiplied together. So we've got 16 is equal to 2 times 2 times 2 times 2. That's a multiplication sign. Those are all multiplication signs. So we got 16 is equal to 2 times 2 times 2 times 2, which is what we were getting earlier. 24, however, is equal to 2 times 2 times 2 again times 3 down there. Right? So this is what we have over here. 16 is equal to 2 times 2 times 2 times 2. 24 is equal to 2 times 2 times 2 times 3. And so we do that same circling thing where you draw a bubble around pairs of identical numbers. So we've got the 2's there, we've got the 2's there, and we've got the 2's there. So our HCF, highest common factor, is going to equal, well, we have a 2 in a bubble here, so we put 2, times 2 in another bubble there, times 2 in another bubble over there, so we put that down here. And so our highest common factor is going to be 2 times 2 times 2, which is, as we got the first time and the second time, is going to give us 8. And that's our highest common factor for 16 and 24. So those are the three different methods by which you can find the highest common factor. Now let me see if I just zip through one more. So maybe I'll zip through one more quickly, and then next video we'll make it a little bit harder. We'll put in the highest common factor of 3 different numbers instead of just 2, and we'll work with some bigger numbers. But for right now, I'm just going to zip through a second example. It's unfortunately going to have to be a little bit quick if I don't want this video to get insanely long. So we're going to do the same thing that we just did, but we're going to do it with some much larger numbers. And we're actually going to take a little bit of a shortcut, because the numbers that we're working with are going to be, we're going to try and find the highest common factor of 57 and 84. Alright, now just by looking at these two numbers, I don't know about you, but I don't want to sit here and try and find all of the possible things that I could multiply together to get 84. I don't want to start by going 2 times 42 and then see, oh, is it divisible by 3 and go that way, and oh, is it divisible by 6, let me try that, and go through the whole list all the way up to 42 times 2. I'm going to be at this a while, and then I'm going to be sitting here and second guessing myself. Did I get all of them? Did I miss something? Am I missing factors? Maybe one of the factors that I'm missing is going to actually be my answer. So we're not going to do that listing thing where we just sit here and go, okay, 1 times 84 and 84 times 1. 2 times 42 and 42 times 2. We don't have that kind of time, right? This is going to take us forever to get through, and then we're not even going to be sure at the end of it that we got all of them. So we're just going to do methods 1 and 3. That's a 3. So we're going to start with prime factorization, and then we'll do the division thing. And the process is very similar. So, well, I mean, the idea is very similar. We just write them differently. So we'll start by doing prime factorization. That's method 1. And we'll build those factor trees. So for 57, 57 is not a prime number, but it's also not an even number. So it's not going to be divisible by 2. But we're going to break it up into something. Now, what are we going to break it up into? If you remember the divisibility rule for 3, if we add up these two digits, and that sum of 5 plus 7 is divisible by 3, then 57 is also divisible by 3. So if we add this up, we get 5 plus 7 is equal to 12. Now 12 is divisible by 3, therefore 57 must be divisible by 3. So I'm going to put a 3 there, and then we just need to figure out 3 times what number is going to give me 57. And just to save a little bit of time, you can go through it on your own as well to make sure that I'm doing this right, but 3 times 19 is going to give us 57. If you want to go about it the long way, you could do it that way. You could do long division and you'd get 19 as your answer. Now here's the thing, 3 is prime, and 19 is also prime. So we're actually done our factor tree for 57. These are our prime factors of the number 57. Alright, so once we do that, we move on to 84. Now 84 is an even number, so that's nice. That means we can already just divide it by 2, right? We get 2 times something is going to give us 84. And so we get that 2 times 42 will give us 84. Right? Now 42 is still even, so I can break that up. And I'm going to get 42 is going to be 2 times something. And if you go through it, you'll get that 42 is equal to 2 times 21. Now 21 is not even, but that's okay. We're dealing with small enough numbers now that hopefully you can recognize just by looking at it that 21 is divisible by 3. Now 3 times what number is going to give us 21? That's going to be 7. And once we get there, we'll notice 3 is prime and 7 is prime. So we're done. So our factors, we're going to bring these 2's down so we don't forget about them. So our factors of, our prime factors of 84 are 2, 2, 3, and 7, all multiplied together. Right? So if we just list those, we get, okay, 57 is equal to 3 times 19. And we get that for 84, it's going to be a little bit different. It's going to be 2 times 2 times 3 times 7. Right? And so now we just want to go through and find, are there any pairs of numbers that, you know, as a number exists in the top line and in the bottom line, and we get that only one exists here, right? We've only got the 3 that's common in between these two lines. So we ignore the 2's, we ignore the 7, we ignore the 19, because none of them are common factors. The only common factors of these two numbers are 3 and, well, technically 1. You could also say 1 is a factor of both of those, but it's neither prime nor composite, and we tend to ignore it generally. But 1 can be important, and we'll come across that in the near future, hopefully. But so here we get that the highest common factor, well, we don't have anything to multiply together other than just that 3. We have a bubble containing 3's inside, so we put a 3 down here. We don't have anything to multiply it by, so that's our highest common factor, just the number 3. There's no bigger number that will divide nicely, that 57 and 84 can both be divided by and give us a nice number. So we're going to do the same problem. We're going to stick with 57 and 84, but we're going to do it the other way now. So I'm going to get rid of that. I'm going to leave the 3 at the bottom for reference to see if we did it right. And we're just going to do it the division way. We're going to skip the listing thing because I don't want to sit here and try and figure out all the possible ways to create 84 by multiplying together two numbers. So we'll start with this 57. It's not even, so it's not going to be divisible by 2. But if we do that addition trick, 7 plus 5 is 12, therefore it's divisible by 3. We put a 3 here. 57 divided by 3 is going to give us 19, if you go through the math. Now 19 is prime, so we already know that 2 isn't going to work, because if it was going to work, it would have worked all the way up there. So 19 is not divisible by 3, 19 is not divisible by 5, it's not divisible by 7, 11, 13, 17, so the next prime number that we can use is 19, and 19 divided by 19 is 1. So we're finished, because we've got a 1 down there at the bottom. Now for 84, it's going to be a little bit longer, because it's a larger number, but also it's an even number, so we can start with this 2 here, right? 84 divided by 2 is going to give us 42. We're not at a 1 yet, so we're going to keep going with this L thing until we get all the way to a 1 at the bottom. 42 is still even, so we can divide that by 2, and we get 21. And now 21 can no longer be divided by 2, but it can be divided by 3, so we put a 3 here. 21 divided by 3 is going to leave us with 7. And then 7 is a prime number, so we put a 7 over here, and we're left with a 1 on the bottom. So now, just as we did with prime factorization, we're going to list the factors of each of these two numbers, the factors that we found in those columns. So we start with the 57. 57 is equal to 3 times 19, which is what we got before. And for 84, it's going to be all of those multiplied together. So it's going to be 2 times 2 times 3 times 7. And then we do the same thing. We try and go through and see if there's anything in common, and we get that once again the only thing in common is this 3 up here and that 3 over there. There's nothing else that these two share in terms of prime factors, so our highest common factor is 3. And that matches what we got before, so we can be confident that we've done this right. If you did the listing thing, you would also hopefully find the same answer that way. So if you want to try it that way, you can. Just be warned that it can be a little bit more time consuming than this method, especially when you're dealing with some slightly larger numbers. Alright, so hopefully that wasn't too fast. I know I was speeding through it a little bit, particularly towards the end, but I wanted to make sure you guys are getting enough actual examples and not just me blabbing the whole time. But so that's the two main ways to do HCF if you ignore that list thing that we did in the middle. This is the way I was taught to do HCF, so this is the one that comes more naturally to me. If you prefer the factor trees, go ahead and do it that way. Anything is fine in that regard. So hopefully that's all making sense. I do have some more examples that we will go through in a future video. The next one is going to be the highest common factor of 3 numbers, and they're going to be a little bit larger than the ones that we've been dealing with so far. So it's going to get a little bit more advanced or a little bit more complicated in that sense, but it's not really that much more advanced. It's just longer, right? It's like when we were doing multiplication for 2-digit numbers by 2-digit numbers, and then we went up to 8 digits by 4 digits. It's not harder, it's just longer. And because it's longer, it's easier to make mistakes because there's more places to make mistakes, but the math doesn't actually get any harder. It's the same simple processes over and over and over again. So once you get a grasp of those processes, you can do any problem. For multiplication with decimals, you could do that once you have the basics, and once you get the basics for HCF, then you can find the HCF of any pair of numbers or any group of numbers, as many numbers as you want. It just gets longer and therefore easier to make mistakes, which is the only way in which it gets harder. But other than that, that's everything for this lesson, and I will see you guys next time. Have a good one.